So last Thursday saya ada kelas master, so I think I have explained that at least in Yulen. So today I think we have pretty much completed the first chapter. Now we can proceed with the second one. So I'm going to share my screen. Entire screen. And let's go on with this one. So basically what we have is the second chapter, second topic is about introduction to programming and also problem solving. What is the approaches or steps that we take in solving problems, engineering problems, hopefully, and how we can use computer to help us deal with that. Okay, so these are some outcomes or objectives. We can appreciate programming as a tool. We can explain about software or programming. We can describe steps for problem solving. We can understand about input, process, and output. And we can go through some sample problems on how to solve this problem, especially not directly into programming yet, but through the planning phase or process using flowchart and pseudocodes.
Doktor.
Doktor.
Apa dia?
Doktor, sorry doktor. Nak tanya, doktor ambil kelas untuk section 7 Sebab
Awak
kalau ikut pada jadual, kalau ikut pada jadual kami section 7 sekarang tak ada programming esok.
Oh ya ke? Alamak.
Ya.
So ni section 6 lah
pada jadual lah, tapi andai kata berubah jadual kami tak tahulah. Kami tak dapat info kalau ada berubah jadual.
Okey. Kejap. Saya pun kejap sebentar. Sebentar. Ya. Betul lah, section 6 tapi awak ada kelas tak sekarang?
Sekarang kami ada English.
Oh, macam tu.
Tu yang kami ada keliru sikit. Sebab English tak dapat link lagi.
Okey. Macam tu awak join. Sekejap saya stop sharing. Saya kena share ni dengan section 6 lah. So sorry.
Okey, so okey doktor.
Okey, kejap Okey, awak boleh keluar lah. Nanti saya share ni dengan section.
Okay, sorry doktor, thank you.
Okay, you're welcome. Section 6. Diorang pun senyap tak tanya link. Okay, so those who are still here, are you guys in section 6? I presume.
Section 6, sir.
Section 6. Okay, welcome to the correct session. Okay, so I thought I was supposed to meet with Section 7, but maybe I did not look at the schedule carefully. Sorry about that. So let's restart this thing. So basically, we are in the second chapter, which is focusing on the problem solving and particularly engineering problems. Engineering problems we can solve through the use of computer programming. So the computer programming part is a tool. So basically, you are solving the engineering things, engineering problems or challenges. But because computer can do a lot of calculation very accurately, and we can make the arrangement so that they can keep on doing the same calculation over and over again. Because otherwise, if we have to do it manually, then it will probably take us a long time, and that is going to make us prone to some mistakes. Okay, I'm gonna show back share my screen. So let's continue. So solving a problem. When solving a problem, the level of abstraction that you choose to look at can influence how easy or hard. Okay, so there are some sometimes the problem is open-ended, it's a bit vague. So there are certain things that you have to fill in, or you have to make assumptions, and you can go bring the problems to many directions. Is it going to be a hard problem or is it going to be an easy problem? Depends on you. So you must also understand the context of the problem. Is it just for training, or is it for something more serious? So you have to take into consideration about the context. So solving a problem involves moving between these levels, between hard and easy of abstraction, more detail, less detail. Okay, so many things you have to make a decision. So that's the thing. So the rule of thumb for this thing is that whatever is given to you as the main information in the problem, you try to achieve those, try to settle those things first. Okay, so do not worry about too much things about this, they say, superfluous stuff that are less important, because if they are important, they should be mentioned in the problem in the first place. So don't make it harder than it is. So you try your best as you can, get the answer, and then try to improve. Always strive to improve. So I guess that's part of life also throughout the history of the Earth or mankind. We human always have to solve problems. So sometimes the more you know, the harder the problem becomes. So if you can simplify things, I guess that's the way to do it, simplify. But certain situation, you must take into consideration a lot of stuff, especially if it involves safety. Any questions so far? Or any opinion you want to share? Feel free. because otherwise it's just going to be a boring one-way street. All right, so you can interject anytime. I'm okay with that. Whenever you have to solve problem, especially big hard ones, some words of advice here: do not give up, because basically all problems can be solved. We can solve all of this problem, inshallah. And the second one, ask more questions. I guess you want to ask enough question, but do not make it more complicated than it is. Okay, especially if that question is going to make it harder. Like if you are supposed to be making a car, designing a car. So I guess one of the question that you don't want to ask is, what's the color of the car? Okay, so just make something and make it black, whatever easy. Maybe you already have black paints in your store. So don't ask, because otherwise it's going to make your life messier. What do you think? Is that the correct philosophy? I guess the third one is good. Break the problems into smaller parts or sub-problems. Break into parts so that it will be easier for you to conquer the problem, to solve the problem. So hopefully by solving this small subdivision of the problems, when we combine them, when we assemble them, the whole problem, the overall problem can be solved as well. Think of the benefits and profits that you'll get. This is kind of like motivation. So after you finish this problem, after you solve this problem, there are like maybe you get financial rewards, you get paid handsomely, and things like that. And then as soon as you develop one solution, start thinking of another way. So this is depending on the time and other luxuries that you have. Okay, if that is the condition, you try to look into other solution, other possibilities, other alternatives. Okay, because if during examination, maybe you have limited time, limited resources. So if you can get one solution, that is already good enough. So that is the situation. But if you have in real life, maybe you are given enough time to come up with several solutions. I guess that is the situation that you have to look into, because the more solution you can widen your choices, so that you'll see a lot more possibilities, and possibly you can also give that choice to your customer or your what call that, stakeholders. Right. Programming is a creative process. Okay, so it's part of design also. Design is also like that. It's a kind of like loop. It's not just one way street. Probably at certain points you have to go back and relook at the problem, or maybe start create or choose another starting point. Okay, so that is the situation for programming as well. Okay, it's a process. It's a process. It's not just one street. Depending on the problem. Easier problems maybe is a easy one-way street, but a lot of other situation, maybe you are looking for optimized solution. So maybe to get to the optimized solution, you have to jump into different places as the starting point, so that it will come to the correct or the best or the better solution conclusion. Okay, one of the popular model is the SDLC. Also don't know what it means. I forgot. So this is SDLC waterfall model or cascading. So starts from the top where you understand the software requirements, and then you do analysis, you do design, do the coding, do the testing, and then maintain it. And then possibly you have to go backtrack all the way until the beginning, and then maybe go cascading down the same waterfall. Okay, and then the process for programming or coding, sometimes programming and coding used interchangeably. I guess for our purpose, they pretty much mean the same thing, I guess. Involves two major phases or steps, 4 steps in 2 phases that require you to do the following. Analysis in step number 1, and also design in step number 2. Then the result is an algorithm that solves the problem. Okay, analysis and design will create the algorithm. Okay, what the heck is algorithm? There's another big word there, algorithm. Anybody wants to take a crack at what algorithm means? Ada yang tahu apa makna algorithm? Algoritma. The algorithm is kind of like the steps or kaedah, or maybe the recipe that if you follow this recipe, you follow the method, you can solve the problem. And probably there are many methods out there to solve the same problem. Okay, and then the second part is to implement the solution. So the first step, problem solving, is like planning phase, and then the implementation part is to execution phase. So that involves coding and also testing. So once you code, you must test whether or not it is answering the problem that you are facing. Okay. So result is a program that has been translated from the algorithm using the programming language. So programming languages are a lot, but in our class we are going to use C++. C++. Before that, I'd like to know whether you guys have had programming experience before, maybe using other languages. Anybody has had that experience? Anyone? Not in the mood to share. Okay, if that is the case, we have to move on. To produce a program, we may use different approaches. One of it is procedural programming. It focuses on the process. Okay, so there are when procedural program is used, usually the problems are big ones. It uses top-down design to model a structure. A big problem is divided into smaller sub-problems or sub-functions. Then solution of a sub-problem actually involves a test or some tests that are grouped as a module or sub-module and coded in a function. Okay, so we'll see this as we go on throughout this this semester. Okay, step one in the design phase or planning phase is the analysis. So analysis is to understand the problem. Okay, clearly define what is needed, is input, as input, what are the process, and then what are the output that we are going to spit out. If solution requires top-down design, then draw a structure chart. So this is a like structure chart. Maybe you guys have seen this kind of chart before. Okay, like organizational chart, I guess. So pretty much the same thing there. Then the next one is step 2 is design the algorithm. Okay, so algorithm is set a well-defined, precise instruction. Like I said, like the recipe that leads to a solution. So algorithm design determine how to take inputs and process them into specified output. Okay. Algorithm must be tested for its correctness. Experience shows that this saves time in getting your problem to run correctly. All right. So program, hopefully we want to get a program or code that is efficient, error-free, and easy to maintain. Okay, so algorithm, in the algorithm phase, we can design it using two approaches. One is pseudocode and the other one is flowchart. Okay, so I want you to give particular attention to this thing because usually they will come out in the test, especially in the first test, in the mid-semester test. So like last semester, we also had this thing. So, and you must know both of them. Either you want to, either the pseudocode or flowchart. In one of the year, I guess the first year I thought we gave the students the liberty to choose either pseudocode or flowchart. But last semester, I guess the examiner asked the student to give both. So you need to know both in order to answer this question. Okay. So let's go through pseudocode first. So it is a precise algorithmic or recipe, if you want to call it, description of the program logic. Okay, pseudocode. Purpose is to describe in precise algorithm, detail what the program being designed is to do. Requires the defining the steps to accomplish the steps in sufficient detail, so that they can be converted into a program. So this is kind of like you want to do the program, but you do not use the programming language just yet. So you describe it in human language, either English or Malay or whatever language that you use. But over here, I guess English for the most part. Okay, and then flowchart is pretty much doing the same thing as pseudocode, but where pseudocode is mentioned in numbered points or bullet points, usually numbered points, like step number one. One is starting, 2 is get input, 3 maybe do calculation or conversion of this value, certain values, and lastly display the output. Okay, and then the closing one end. So that is the situation in pseudocode. As we will see in hopefully 1 or 2 examples. But flowchart is doing the same thing, but using these boxes and also arrows. Okay, so there are arrows will connect from one box to another. This is terminal, so you must begin your flowchart with this thing and also end with this thing. So the beginning is start, the end is end. Then at a certain junction, you will have to make some decision. So you use this diamond box and put some question in the box. What are the decision that you have to make? And then connectors, preparation using this. I don't know. This is kind of like hexagon. But this is more common, the regular rectangle. This is for process. So if you have to do some calculation, conversion of unit, things like that, so you use this box. For input output, like when you have to ask input or get input from the user, you use this. What do you call this? Like rhombus. I don't know what you want to call this thing, but this skewed rectangle. So this can be both for input and also for output. Sometimes if you want to display the output, display in the monitor, so you just put that process in this box. So if you have like a side calculation, like in the function, so you can put it in this kind of box. Okay, so we'll see some examples later. Okay, and then step 3 is coding. So this is beyond planning. So this after you are done with the planning, and what call that? And that planning can be either using pseudocode or using the flowchart. Then you go to the next phase, execution. You have to do the coding. So now you have to translate whatever the wordings that you have in the pseudocode or in your flowchart into the real coding in the real programming language. So that depends on what language that you want to use. So if you use Fortran, it's going to be different from using C, and even C and C++ will be different. And then they have this thing called C#, okay, or C#. So all these things will be specific to the programming language. Like I said, programming language is a perantara. It's like a bridge between us human. Are you guys human? I guess you guys are human. If you are a robot or some alien beings, you're not supposed to be in my class. Okay, so we human cannot speak directly to the computer because computer works with 1 and 0s. So the programming language that we choose as a tool will be the converting or translating from our language into the computer language. So the programming language is somewhere in between the human language and the computer language. So it's not exactly English, but it's using words that we can understand, especially in English, from English. Any questions so far? Or maybe you want to give answers? That's fine. You guys probably know something more about this thing. All right. So as usual, when we do the coding, probably there are some errors, either from your negligence or from ignorance or something that you did not. Maybe you have to use several different languages throughout your career or work. So maybe you have some commands that are not supposed to be used in that particular language. because sometimes the comments are a lot. Usually the comments are going to be different. Maybe the syntax, the way you want to code it is going to be different. Like in some like A1 plus or A plus B, and you have to define first what A probably equals to 1, B equals to 2. So A plus B is representing 1 plus 2. Okay. So that's the kind of things. Sometimes even the equal signs is different from one language to another. I guess there's one language that you need to have the semicolon before the equal sign. Okay. Some programming language will require you, like in C++, you have to end. Usually all the lines must be ended with a semicolon or semicolon. Okay. But if you use MATLAB, that is optional. You can put a semicolon or without the semicolon. Okay, and then whatever it is specific to the programming language that you use, you have to do corrections to the codes until all the errors are corrected. If they are not corrected, then you are not going to get your solution. Okay, and then you have to test the program. So always test it. Maybe try to make it as robust as needed. Okay, repeat step 4 as many times as necessary to validate the result. So how do you validate the result? You start with something that you know, probably data that is well known or maybe that's commonly known. So you try to use that same data and see whether the output is going to be correct. For example, if you do a programming language program that converts what call that the temperature in Celsius to temperature in Fahrenheit. So you must know what is the freezing temperature for water, for example. What is it? What is the freezing temperature for water? Hello, anybody there? 0 degrees Celsius is the freezing temperature for water. And then you should know what is the freezing temperature in Fahrenheit. So, apa? 32. Okay, so those are known values. Similarly for boiling temperature for water. So for water is 100 degrees Celsius. And then you must also try to find out what is the temperature, boiling temperature for water in degrees Fahrenheit, 212. So any values in between 0 to 100 degrees Celsius, you can try. To convert and see that whether you are getting the right answers or not. Okay, so that is a very important step, which is testing your code. So this is one example in problem solving. So you'll see problems like this a lot in this class. So for example, your summer surveying job requires you to study some maps that give distances in miles. You and your co-workers prefer to deal in metric measurements in kilometers. Write a program that performs the necessary conversion. The program will display the distance in kilometers. So you probably, what is the input? Input will be the distance in miles, but the output will be converting the distance from miles to kilometers. Okay. So you must know what are the formulas needed, okay, and things like that. So this is using top-down design. Okay. So the analysis part is to identify what is it that your program needs to do. So basically, it's just a converting miles to kilometers. So the main thing that you need to know is 1 mile equals 1.609 kilometers. Okay, so in this step, you need to identify what is the input, which is miles, big M. Then the process, you have to use the formula given, and then in general, the K kilometers is equal to miles times 1.69. So if it is 1 mile, it's going to be exactly 1.609 kilometers. If more as it go more or less, it's going to times that with that 1.609. Okay, for the output, you are going to display that result, which is K. So just display that in kilometers. So whatever that answer is, it'll be in kilometers. Okay, so this is the the organizational chart. The main, so the main will have the input, the conversion, and so the output is going to be displayed. Okay, so for the algorithm, so this is the part that you can choose whether to use pseudocode or flowchart or both. Okay, so like last semester we asked the student to give both. So let's take a look if we use the approach of pseudocode. So it'll be numbered. It'll be numbered. So number 1, numero uno, must always be start or begin. Okay, number 2, okay, we start to get our input. So here we can outsource the task of getting the input to a particular function. So we have a function for the input. So where in this function, it will read the distance in miles. Okay, and then it will return miles back to the main program or code. Then the second one is to do the conversion. This is the process. Okay, so this is where the equation K equals to M times 1.609 is going to be used and calculated and then return the value to the main function. Okay, and then the fourth one is to display, whether just display the value in the on the monitor, on the screen, or you want to print. So it's up to you. And then the last one will be to stop or end. Start, end, or begin, stop, something like that. Any questions so far? So this, as you can see in the pseudocode, they got to be numbered and must begin with the start and end with the stop. So either you start or begin or stop and end or end. And all the wordings here are normal human language or sentences. So there's no command here. Okay, so you do not have to use the specific computer or programming language commands yet. Okay, similarly in the flowchart approach, you can do the planning as well. So here we have the main on the left. The main flowchart is on the left, where we start, and then we have the input, then we have the process, where we do the calculation, and then we display, which is the output, and then that's about it. We end. And so as you can see here is the function. So we have three functions here. One is for the input, one is for the calculation or processing, and the last one is for the output. So for each of these function, we have flowchart. So this is flowchart for input. Okay, flowchart for input, and then we have flowchart for conversion. So see the process is in this rectangle box. So read distance in mile. So this is getting input. So we use this rhombus. Rhombus kita panggil ya. Saya tak ingat. I think we call it rhombus. Then we return the value from here. We return the value to the main function or main code. And lastly, we have the function for display. So this is probably just display on the screen of the computer. Okay. And then we get to the next step or next phase, which is execution. So this is where we do the coding or the programming, the actual programming. So in this case, we have the C++. So C++ will be our tool here. Okay, so at the top here we have comment, and sometimes we call this the preamble. Preamble, where it describes about what the code is all about. Okay, sometimes if this is the exercise, then you have to turn in. You probably have to write your name here, write your class, section 6, section 7, BMKU. Or you guys BMKK? BMKU ke BMKK? Okay.
BMKU.
BMKU. Okay. All right, and then we start with the actual programming. So here, let's go through some of it. Where we have the top part is always hashtag include IOStream. Hashtag include IOStream. And at the end of that line, we do not have semicolon. Then the next line, second line, is using namespace std or standard. And then we have this semicolon. Okay, so this standard, you always have to write this thing down. If you don't remember anything else, remember this. Okay. And then the next part, double input. So this is the part where you want to call the input. The input. So here we have double input. Global declaration. Then void display. So this is like dealing with functions. Later on, when we get to functions, we have to do the declaration first. Declaration, and then after declaration, later we have to define what are those functions. So here the functions are not defined yet, but we have to declare the functions, So we have input, we have actually convert first and then display lah. So but the turutan tu is not important lah. As long as you declare them over here before the main, I think that is good. That is good. Then we have the main body of the program, and this is also a function. So these are functions, and this is also a function. Main function is also a function. So in this, we declare again, we have input M, and output is K. So this is going to be the type. So double is the data type. So within this thing, we have we are going to call these functions that we have declared. So the first function that we call is called input. The second function that we call is convert. And then the last function is display. Then to close the main function, we usually have to write return 0 semicolon and then close it with this curly bracket. Okay, and then we have this thing double. Okay, in this approach, after the main function, we define what are those functions. Those three functions that we already declared. We declared this function before the main function. So here we define it. We define what are the functions. So for input, this is of the type of double. So within this one, we declare miles is also double data type. Then we cout is to display this particular statement. So to do that, we have to follow this syntax or this way of doing it. So the text that you want to display must be within the double quotation marks. Double quotation marks. Okay, please enter distance in miles. So that one will be displayed. And then whatever answer that you give or you type will be read as miles. So we will assign that number to this variable called miles. Okay, and then we return miles to the main function. Similarly, for this one, we use double km. So this will be in kilometers. And then distance. So when we here the input or the function, okay, when we learn about function, we'll understand this. So here, this one, this function does not have any input. But here, this function will have the input to that function within this parenthesis or bracket. Parenthesis. Okay, so double, the type is double, and the name of the function or the variable is distance in miles, which is probably this thing. So we'll take this one, put it into here, and that'll become the input to the conversion. Okay, so and then we can calculate the conversion using this equation. Notice here, the programmer tries to make it a distinction. So this one is supposed to be big K and this one is supposed to be the big M, but it doesn't have to be the same thing. So when we define it separately in a separate function, so you can have another variable which is not necessarily this one. It's not necessarily this one. So okay, and then lastly, the last function is display. So again, the information from KM here, you can put it here. So by right, I can just put KM here, but we can make it something else. We can because we do not want we want it to be more general than specifically transferring directly from this output into this input. Okay, might seem a bit confusing right now, but I guess it's just trying to make the program more robust or more general. It's like the input can be any. The input is supposed to be a student, so it's not necessarily any student. Can be any specific student, but you know, the probably is going to be output from the previous calculation. It will be the input to the next one. Okay, so basically the output from here will be the input for this one. Okay, then if you look into this example, basically it's going to show that please enter distance. So that is from the input stage or input function. Then you'll do the calculation. So the calculation is not going to be visible here, but the last one will be distance in kilometers. So this one is the third function, which is to display the output. Okay, any questions so far? Tak ada?
Tak ada, Doktor.
Tak ada. Okay, so I hope you understand that. Boleh faham yang tu? Boleh ikut senang ya.
InsyaAllah, Doktor, insyaAllah.
InsyaAllah, bagus. That's the spirit. Betul ke spirit? I'm gonna try to copy this thing and maybe over here can go to programmers. So programmers, if you open programmers, usually or C++ shell, usually you will already have one function or code. It's already written there, so I can run this thing and see the output over here. Okay. So I'm gonna override with this one. So it's not complete yet. I have to go to this one. Copy all the three functions. And hopefully, if everything goes fine, we can run this thing and it'll give us the output. Run the program as planned. So if it doesn't scream at you or give some error, so meaning it is okay. Sometimes if you just copy from the notes like I did, just copy and paste, sometimes there are some corrections that needs to be made. So you have to go and do that. Usually, maybe it will mess up in the quotation marks. So maybe you have to replace those quotation marks. Maybe in the future we'll see these kind of problems as well. So what number should I put here? Like if I put 3. Uh, 3. So we'll convert that 3 miles to kilometers. So you can double check that. Maybe take out your calculator. 3 times 1.609. That is 4.827. So that is correct. So you can probably try that over and over again to see whether you are always going to get the right answers or not. Yeah. Okay, we can try to run that again. If I put just 1, so 1 will be 1.609. All right. I think I'm gonna stop here for now. Do you have any question? Are you guys having fun? How's the Eid celebration?
Raya bandar ada, Doktor.
Ada banyak duit raya?
Dah besar tak dapat, Doktor.
Tak dapat? Kesha Nisrina macam mana dapat duit raya?
Tak juga, Doktor.
Tak dapat juga? Allah. Ya, okay. Kalau dapat boleh share lah. Sebab diorang kata sharing is caring. Anywho, hope you guys still have fun with the celebration, and mungkin UTM pun akan ada celebration peringkat universiti. So kita tunggulah jemputan daripada yang berbahagia NC. So you guys have a great day, and inshallah we'll see you next week lah. Next week online ke ataupun face to face?
Face to face, Doktor.
Face to face, okay. Setakat ni macam tu lah kita punya perancangan. Because I guess there are some new development, not really because of the Hari Raya, but new development because of the world crisis that particularly affecting the oil supply. So that is going to affect us a little bit. Because some universities have already decided to go online even for next week. But for us, we I guess stick to our current arrangement to have face-to-face for starting next week. So you guys stay put, stay strong, and be hungry for the knowledge, and take care. Assalamualaikum, and thanks for coming. Bye-bye.
Waalaikumsalam. Terima kasih, Doktor.
Salam, thank you, Doktor.
Salam,
Okay.
thank you, Doktor.
Thank you, Doktor.
Okay, you're welcome. Bye-bye.
Thank you, Doktor.
You're welcome.
Thank you, Doktor.
All right.